Hello everyone. In this tutorial, I'm going to explain how to measure or take off quantity of lintel roof. This is the side. Lintel roof is the type of roof that it's slope at one-sided roof. Sometimes, okay, for example, this one projects outside of the wall, and there's some roof that's lintel roof that is being hidden. What I mean by is being hidden is that there's this wall are parapet. This wall will be a parapet wall and the roof will be inside. So anybody viewing it from outside won't be able to see the roofing sheet or fascia board at all. This external block wall will serve as parapet wall. We cover it so the roof will be hidden. But this one projects beyond the building. So let me show you another 3D of the lintel roof. Okay, this is another perspective. This is another one. So it's slope to one side, that is the right side. This is the section. This is the section. And it's elevation. So let's keep moving. This is the roof plan, and this is the floor plan. So now, firstly, let us start with um roof frame, and we're going to proceed. We're going to proceed with wall plates. Wall plates is being positioned based on this lintel roof. The wall plates will be positioned on the walls, on the external walls. Sometimes it's being placed on the external wall, and sometimes uh, it's being positioned. You have two methods by which the roof can be constructed. Some people install the roof frame before. Okay, let me show you something. Okay, so some people install the roof frame on the external wall before setting the external wall block, and some other also install or fix the wooden frame after the external wall has been set out. So now let's keep moving. So now for the wood or the wall plates, so I'm going to fix, for example, if this is not lintel roof, if it is pitch roof, the wall plate will be placed on external wall. So now the reason why you are placing the wall plate on external wall is that the tie beam or joist will be placed on it, to rest on it, and this wall plate won't be on external wall only. It will also be positioned at certain interval between the building. And the joist, okay, before you reach joist, let us first done when you are done with the wall plate, you now move to joist. For I want to explain something. And the width of the building is what, 14.98, and length is 12.653. Okay, so now let's keep moving. Just name this one as wall plate. Wall plate. Make sure that record mode is at point to point. Place is at the center. So so they're done with the wall plate externally, and you also fix it internally so that the joist or tie beam you rest on it, you're able to rest on it. So now this is you have 14.9. Let me divide 14.9. Let us say 15 meter. 15 meter divided by 3. That is 5, right? 5 meter divided by 4. 15 meter divided by 4. That is 3.7. Yeah. That was divided by 3. By 3. So when divided by 3, which one is more advisable? I'm coming. 15 divided by 4. That's 3.7. Okay. So now just continue. Click on it. Press N. So you divide it by 4, right? So just take this one as 1. Press N. Yeah. Escape. So the function of this internal wall plate is that it will enable the tie beam, because the tie beam run on short span of the building, or joist run on short span of the building. So you have to fix this wall plate internally so that the tie beam or joist will rest on it. So we are done with wall plate now. And what next is joist or tie beam. Let me show you guys what I mean by joist or tie beam. This is the joist or tie beam. It's run, and this is what I mean by internal wall plate. This is it. It's rests. The wall plate is placed on the wall, and the tie beam or joist is also rest on it. You understand me? Also rest on it. So what I'm going to do now is work tie beam or joist, and tie beam also run from, for example, for this building now. For this building, okay, good. I'm coming. I want to show us elevator section. The tie beam will run from this point to this point. Okay, from this point to this point. So this building now, that means that this building framework is done or is positioned at the back of the external wall. At the back of the external wall. It's back of the external wall. Okay, good. Like I said earlier, some people when they are constructing their roof frame, they make sure that the roof frame is done before the external wall. Some also do it after the external wall. You understand me? So I prefer I prefer the roof construction after the external wall. But for you guys that want to construct it before the external wall, that is why I fix the wall plate externally. You understand me? Now I fix it properly externally. So now I left the tie beam now. Tie beam run from this point. The tie beam will enter if the external walls, if you want to set the external wall first before the frame, that means the tie beam, you have to create hole inside the block wall and insert the tie beam. That means tie beam will run from this point. It won't read the external part. So it stops somewhere here. It will start somewhere here and end somewhere here. So now for tie beam or joist, click on joist, pitch is 0 because it's horizontal work. Tie beam or joist. Joist type 50, the size of the formwork of the wooden 150 then pitch 0, select parallel. Okay, the reason why I'm going to select this parallel is that you have vertical, horizontal. The reason why I'm selecting this parallel side is that, for example, if I draw the line horizontally, the wooden is also position itself on this. It is also parallel to what I've drawn out. So center to center 1.2. What next? Yeah, click OK. Make sure that record one is at point to point. Click on escape. Oh, sorry. I didn't. Just double click on this. Drag it here. And double click on this. Okay. Yeah. So click on it. Click on draw joist. So now I want this tie beam to run horizontally like this. You understand? It will run through the short side of the building. So just pick this side so that the formwork and the wooden will be parallel to what I draw out. So can you see it now? We have this is how the plan. This is how the tie beam will be positioned. Let me hide this one so that you're able to see it clearly. This is it. Let me hide it. Okay, don't worry. Yes. So this is how the joist will be positioned on the wall. Let me hide this one. So now we are done with tie beam Then what next? King post. King post. Let me go to the section. The king post is the highest point or the riser of the wooden frame. The riser of the wooden frame. This is the run, this is the run side, and this is the riser. And this area is the slope area. I mean the pitch slope of the roof. So to calculate or to measure for the king post, that means the king post will run from this point to this point, from this point to this point, and from this point to this point. So now to calculate for king post now, what I'm going to do now is that click on this plugin. So we have king post height, building length, center to center. Okay, good. So let me explain this one. This king post height means the height of the king post here at this point, at this point, at this point. Then building length is where the king post will cover. To cover from this point. The dimension of this building from here to here is okay. I will show you guys. So I will show you guys. I will dimension so I will to show clearly. So that is the building length. So this one too, I'm going to dimension it. I'm going to dimension it. So that means that this building length will be divided by the center to center, which will give us numbers of the king post. You understand me? Just click on this. So let me dimension it. Or it has been dimensioned. No. So let me dimension it from this. Yeah. And we have this one here. This one is um 2.153, and this is 1.393. Escape. So for you to determine the height, it's easy for us to determine the height of the king post from this point to this point. You understand me? So for you to determine the height of the king post from here, for this side and this side. So I did something here. I dimension from this. Okay, no, I want to check something. This dimension. Okay, this dimension 9. Okay, here is 1 point. I have 1.5. Okay, 1.5. So also from here. Okay, good. From this external wall to this external wall, I have 1.73. Okay, from this external wall to this external wall, I have 6.8. Okay, good. Let's go to section. Is it 1.7.73? Okay, so I have 1.73 from same point to this point, 6.8, like what I explained to you on floor plan. What I'm trying to explain is that this one, now you already know that this one is the first king post side is 2.1. So the king post for the second point at this projection, I mean this area, for this point, determine the height of the king post here and this side. So it will be this one is 2.1, right? So to determine king post that is here, just dimension it at this point. Let me check. Okay, from the grid 9. Okay, start from the grid 9. Okay, you have 1.78 out of this one. That's the grid 9. Okay, you have 1.09. Okay, good. Now let me write this one down. I'm coming. You have 1.73. No, I mean 1.79. You have 1.09, and first one is 2.1. Okay, good. So we'll go back to floor plan. Okay, king posts. King post. Just name it as king posts. A. Good. King post height is 2.1. Then building length. I mean the length of this building here. You have 9.13. 9.13. Center to center 1.2. Yeah, 1.2. Yeah. Just single click. Just click on it like this. Okay. So we have 18.1 meter. Let me show the legend. You have 18.1 meter. Okay. 18.1 meter for the king post A. So for the king post B, king post B, what is the height? 1.79. 1.79. What is the width or the building length? You have, I'm coming, 2.153. 2.153. Center to center 1.2. Click on OK. Yes. Escape. King post C. 1.09. Building length for this one is 3 point, I'm coming, 3.9, no, 1.393. 1.393. 1.2 as center to center. Okay, yeah, you have 18.1, 5.0, 2.1. So now we are done with king post, right? So after king post, you have rafter. Rafter also cover, let me show you guys rafter. This is the rafter. Rafter span through like this. It's also, you also maintain it at the same level, the same line with king post. This is 1.2 center to center. Okay, so and we are with I've been taking off quantity or measuring some drawings. I haven't seen any design. I haven't seen any design with um pitch slope. I haven't, except the riser here. I haven't seen design with pitch slope. So now I want to explain something to you guys, because when I'm going to take off or measure for roof rafter, I'm going to consider the roof slope. So good. Let me show you something on Revit. on Revit. I'm coming. Okay, this is the building width. I'm coming. I want to show you something. 16 points. Okay, good. Okay, I understand. I know where I got it. Let me go to roof plan. Okay, because the rafter covers start from the edge of roof. Okay, let me show you the section. Let me show you section. Where is section? Let me check this one. The roof rafter start from this point at the if, start from here and terminate there. It doesn't start from the external point of the wall and stop here. No, it starts from the edge of the if and stop at the other side. So that is why we have on roof plan. That is why we have. Don't focus on this 16.32. I will explain that one. But this is the width. I mean, this is the side. This is the area that a rafter will cover, which is 16.18. It has been dimensioned already. 16.18. Okay, good. Now, since there is no pitch slope, we can determine that by ourselves. So these are determined. I draw this one out at 16.8, and the riser, which is the highest point of the gimbal, which is 2.1, shall now draw it and connect it together to give me 7.4. Understand me? Give me 7.4. So good. See me 7.4, and the rafter is 16.3316. Let's go back to PLANSWIFT. So just click on area, click on joist, name it as Rafter. Pitch. The pitch is what 7.4, right? 7 pitch slope or degree 7.4. Start center is also 1.2. 50 by 150. But in Nigeria, it's no more 50 by 150. Everything has changed. If you go to market, you can't even see anything like 50 by 150. That's reduced. The best thing is to go for maybe 75 by 150. So center to center spacing, that is 1.2. Okay, make sure that record means I point to point. This is where the roof covering, I mean the roof eave terminates. This one is the gutter. So pick each one here. Just trace the edge of the roof. So the reason why, okay, after this roof rafter, I'll just proceed with for line. So this one is just the facial board. Yes, this one is the facial board. So don't click on it. So after roof rafter, we proceed on for line. Struts take a lot of time, which you know manually. So you have to be patient. You have to be patient. You have to be patient. Okay. Mm, 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 mm. Yeah, click on escape. Click on escape. So now it's also parallel. I'm going to draw out, going to parallel with the roof rafter. Click on draw joists. This just click on it and draw it to this side. So these are the rafter with position. You have different type of rafter based on the length. For example, which one is this one? 4, 16 points. Good. The reason why uh the reason why I didn't I want to explain this 3.16.1 one what 16.316. Yeah, so this is it. We have four numbers of 16.31 coming, and this is it. 1, 2, 3, 4, the longest side. So that is what I'm trying to explain to you on Revit. That the longest side will be 16.316. So here is it now. So try to understand what I mean by giving you guys explain to you how I got the 16.316. So now this is how to calculate or to measure for takeoff or measure for rafter roof rafter. So after roof rafter, now proceed on um line. Line. So click on area and line. Do you know that line also run vertically? Vertically on rafter, and to determine the quantity. Okay, let me show you this one. To determine rafter run horizontally, like vertical like that, like this, on this slope length or inclined plank or wooden. So it is positioned on it. This length will determine the quantity of how the line will be distributed on it. Okay, good. So now here, click on joist, and the reason why I'm going to add slope to this line is that, like I said the line will be distributed on the inclined plank, and if I shouldn't add any slope here, that means the line will be positioned on only the tie beam, be positioned on only the tie beam. So at least the addition little addition to the each length of the line will give us, will be added to maybe the quantity of the pollen that will be distributed on the inclined plank. That is why I want to add a slope. That is 7.4. Line 50 by 75. 600. Okay, 600. Point to point, just trace this out. Escape. Line, click on it, click on draw, So we want the power line to be vertical like this. And to be parallel to this line I'm drawing. So yeah, this is the power line. This is being distributed on the roof. On the roof rafter. Yeah. This is the power line. This is being distributed on the roof rafter. This is the power line. So after power line, we're going to proceed on strut. Let me first hide all this one. Let me hide it. Okay. Let me hide it. Okay, good. What did we need to measure this power line? We need the building width center to center. Okay. Let me come back to floor plan. Okay. First one we are going to do now is that the power line will run from here to here, 5.51. Let me check this section. 5.51. Okay. External. Okay. 5.5. Okay. It's run from 5.51, right? Okay, good. 5.54. So what is the building width that we have here? This one is run from here to here. We have 825. Okay, 825. 825. You have to come down to roof section. I will scale the vertical. Let me scale it. Vertical side is 6.3. 6.3. 6.3. So let me reconfirm. 3.6. Okay, it's correct. So yeah. So what I'm going to do now is that I want to take call for the struts. The width is 8 point what? 800 and 825. Okay. The width is 825. Click on strut. 0.825. Center to center is also 1. Center to center. Yeah, 1.2, 1.2. So I'm able to determine the numbers of what I'm going to draw out here. So the strut starts from here. Start from here. Let me see 5.5. Okay. Stop somewhere. Yeah. Click on escape. And we have 22.9 as the strut that cover this area. Then, then the next one, just go back to floor plan. Let's cover from this point to this point. That one cover from, let us ignore this area, just take it as one. You understand me? So the dimension, just take it from, just stretch this dimension. Yeah, just ignore this small area. So just take it as one from this point to this point. So the building width is 7.10, right? 7.10 by what? What is the width of the building? By 14.98. Okay. You don't need by 14.1. Just trace the maybe main section. So we have 7.10 as the building width. 7.10. 7.10. 7.10. Center to center 1.2. Center to center, you're able to determine the quantity of what you're going to trace out here. Anything we trace out here will be multiplied by the quantity. So then that you are tracing the longest side of the building, or the width of the building, which is total of all this section. Yeah, click on escape. So you have 197.3. Let's go back to floor plan. So you have done the strut for this area. So it remains strut that will cover this area now. This area from here down to this side. Something like this. You understand? Let me draw you something out so you're able to understand what I'm saying. Just pick this point. Yeah, that's good. That will cover from here to here. You understand? That's what I'm trying to explain. The remaining one I'm going to do now is just cover this area. Let me draw another one. This is what I want. This is what we want to do now, right? So this is what we've done. I want this thing to be more clear. This is what we've done so far. This is what we did now. Before we start, and this is what we did. And this first one that's yes, okay. So this is the first one that we did. Click on escape. This is the first one, this is the second one, and this is the third one I want to do now. So the third one now, let me hide it. So the third one now, the width is 3.34, 3.34, which will cover 11.46. What is 11.46 on the section? 11.46 on the section. You have 1.5. 11 point, okay, this is 11.46, right? Okay, good. 11.46 cover from here to here, and the width is what? 3.34. The width is 3.34. So now click on Strut 3.34. Center the center 1.2. Click OK. So the strut will cover from this point to this point. So now what I'm going to do now is that you can pick it from here or pick it from here. So just trace the existing one to stop here. Click on escape. You can change the color if you like. So you can change the color maybe to identify it. So you have done with that one. The next one is this. I want to work on this. Yeah, good. This one is 1.5. No, not 1.5. The width, right, that we cover. Okay, the width is what? Is 1 point. We have, let me dimension it. That's 1.2. Okay, the width is 1.2. And let us check the section 1.5. 1.2. 1.5 like this. Okay. 1.5. 1.5. Then the width is 1.2, right? So let's click on Strut 1.2. Center the center 1.2. So the strut will cover from just only this area. Yes, just trace it out. Yeah. So you have done with that one, right? Then after that, go to floor plan again. In this one. So you are left. Oh, sorry. I dimension it from here to your right, 11.46. So I have to extend it. Yeah. So good. So now it remains this area now. This area that I haven't covered. And this area is what? Let me dimension. Determine the this one is 1.58. Let me move this one so I get to understand. 1.58 by what? 4.65. 1.3. 1.35. Sorry, 1.35. 1.35. Okay. 1.35 by 4.6. Okay. So now the width 1.35. 1.35. So that's it at 1.2. Click on OK. So going to cover from here, from this point to this point. So we pick it from here, just trace it out. It's going to terminate somewhere. Good. Escape. Can change the color to light green. So that is how to calculate for roof struts. To calculate for roof struts. So now we are done with that. What next? The fascia board. The fascia board, let me show you the 3D. This is the fascia board. This is the fascia board. This is the fascia board. The fascia board will be in linear. Will be in linear. So Where is the reply? Okay. The facial body, we are going to trace. The facial body be in two form, be linear and segments. The segments we cover this area, the slope area, this vertical one. You understand? This vertical side. You also click on segment, click on beam two, name it as facial board. The slope is 7.4, right? 7.4. Witness. Yeah, yeah, yeah. Click on it. Just click on it straight. The facial board. Don't stress yourself. And just this is two sides. So that will be 14.3 by 2. That is one side and this is the second side. So for linear, just click on this, name it as facial board. Facial board. Start. Yeah, it should end somewhere. So facial board. That will be addition of these two. We now multiply by 2 to give you total length of facial board. So you are done with the roof frame. So you are left with what? Roof covering. Let us trace this one now. Yeah. You are left with roof covering. So you're also making use of roof covering, which is 7.4, 7.4. Record mode point to point. Just trace it out. Escape. Show label. So you have 221.73 at the square meter of the roof covering. So now it remains gutter. The gutter will be at the edge here because the building slope to one side. Why is it? I'm coming 3D. Okay, it sloped to one side here. So the roof gutter will be at one end. The roof gutter will be at one end, which is very easy. Just use one length of just use this one as 13.89 as the roof gutter. Let's cover this 1, 2, 3, 4, 5. You understand? That's why the roof gutter will be positioned. And including inside this area. So let me just draw it out. Roof, roof gutter. And then draw it out. Yeah. So it will be fixed at this edge. So that is all for now. Anyone that is not clear can drop your message on comment section box. Thanks for watching.